Rahulji, can I request you to speak for 1 or 2 minutes on the context for this presentation on RO? Rahulji, can I request you? Yes.
RO, if you see the history of RO, when Israel got their motherland, they were surrounded by sea all around and enemies. They had no fresh water. The rainwater is also very meager. So to support life, all they had to do is with seawater. And desalination, sodium chloride is harmful to the animal body. So RO appeared. Now, since the RO was very effective in filtering the minutest of particles, including salts and other things, secondarily, it found its application in sewage treatment, which was absolutely unnecessary because minus shoreline areas. For example, Madras is a shoreline city, but there is ample rain. So desalination has other shortcomings also. It has challenges, it has benefits also. And I'm sure Mustakim will take care of that. But whatever tertiary treatment that Dr. Snellonde mentioned, this is not the function of RO or membrane filtration. But then there are applications and issues. Every site has a different weather and circumstances and challenges. So technologies come to help. And Gulf countries especially, they found a very good solution out of this RO research coming from Israel. Thank you, Mustaqim. Over to you.
Lovely. So thank you for that context setting, Rahulji. Over to you now. To the rest of you, Dr. Mustakeem is a PhD from the university in KSA. He works from out of Al Jubail, which is one of the 4 or 5 large cities of Saudi Arabia. His time now should be about 2 hours behind us. Over to you, Mustakeem.
Okay, thank you, sir. I appreciate. I think Dr. Rawal already set a very nice platform. I will skip some of the slides. Let me share my slides. Okay. Interesting.
It's buffering.
Yeah.
You got
Are
it?
you able to see my screen?
Yeah, perfect.
Oh, okay, that's great. Okay, so I mean, Dr. Rawal already mentioned a couple of slides, but let me just quickly see what I will describe in this. Sir, how much time I will have?
You can take up to about 40 minutes or so,
Okay.
so that you will
Okay.
get more time to listen to the participants.
Okay, I will take 40 minutes and then we will move to the discussion session.
Yes, thank you.
That's great. So I will describe, I mean, why the desalination was needed, and also what are the types, what are the different ways people do the desalination in the world, and what is the minimum energy concept in desalination. What does it mean when we talk about the energy, and what is the process itself it has, and the pretreatment, what is the pretreatment, why it is important for the desalination, specifically for RO, and what energy consumption means in general. So there is a difference between its minimum energy and the energy consumption itself. And then I put some of the slides regarding the environmental concerns, and which is basically one of the climate change area what we talk right now. And definitely our very important, very healthy discussion session is waiting for everyone. So as Dr. Rawal already mentioned, we have some issues that the water concern everywhere. Some of the lands that geographically are like something like this, they don't have water themselves. So there are multiple reasons, and out of that, there are some places which Previously we had water, but they are now going to water scarce regions. There are multiple reasons, for instance, population growth, industrialization, climate change, multiple reasons. Now, out of that, what are the, I mean, as we know, there are the decrease in the normal rain patterns, and also lot of the water table is going down and the water quality is going down. So what are the ways that we can get drinking or potable water for us? So one of the way that possible ways the recently scientists explored is the desalination. What it means, we have, like I would say in the right side of the picture, you can see it's here, the 96% of the water is ocean water. We can take that water, that advantage of that water, and can get benefit of that thing to take potable water from us. And this is the process we call as desalination. The seawater is very heavily salted, and then we remove the salt and we use for our purpose. So so in seawater, we have around 3.5% salt. What it is mean in terms of the milligram per liter is 35,000, or sometimes it has 45,000. For instance, the city I'm sitting here right now in the eastern province of Saudi Arabia, it reaches salinity until 50,000 ppm, so milligram per liter. So there is a lot of variations in the water composition. But what is important here, that there is some kind of salts, specifically sodium chloride, which basically mix with the water. It is like a soluble salt, and then we have to remove, because it make the coordination sphere with water, so it has to be chemically separate from water. It cannot be filtered. So there is a difference between the filtration and desalination. Filtration means you filter out something which is visible or which is physically, I mean, present, not chemically dissolved in the water. So this is kind of the all. You can see right side, the sodium atom is like bonded with multiple water molecules. So to separate the water molecules or sodium from this one, because if we move water, sodium automatically move with water. So we have to find a way so that we keep the sodium away and only move the water. So the first approach, what I put in the bottom, is the thermal approach, which is basically we were using till 19th century, or I think I would say mid of the 20th century. So this is the thermal, we call it multi-stage flash or multi-effect distillation. It was very much used for different versions. And what we do here, we evaporate the water. When we evaporate the water, you see these molecules of water, they evaporate because they are in liquid form, and with the sodium is a salt, it is a solid, it cannot evaporate. So what we evaporate it, and then we make it vapor, and after vapor we condense back to the liquid, and this is we call as thermal desalination, and it involves the energy. I will discuss it later. Now the second approach which we are focusing today is the reverse osmosis. We call this a kind of the physical process, physically removing. It means we push the water through a membrane, we call it selective membrane. That membrane is the reverse osmosis membrane. So we have to actually if you see the reverse osmosis here, so reverse osmosis is a type of the osmosis where we have two different kind of the salt in between. So reverse osmosis in general, what we will have, if you can see here, so there is a natural diffusion of the molecule from one side of the membrane to the second side of the membrane. And if you can see a little bit the process on the right side, we have a pump and we have a membrane. What we do in reverse osmosis, we reverse the process of osmosis. Osmosis works when we have the like from the higher concentration to the lower concentration. So what we do reverse the process from lower concentration to the higher concentration. What it means, because there is lot of salt in the seawater, and naturally the salt will move to the other side, but what we allow the water to move to the another side. Now because the membrane is very important and very big aspect of this whole process, let's see what is the membrane in RO. So RO membrane development has two phases basically. The initial phase, which started from the actually the cellulose acetate membrane. We call this tricellulose acetate membrane, or we call this CTA. So this CTA membrane basically started early, and then we have TFC membrane later, which we are right now using in present time. So this cellulose triacetate membrane is basically kind of, I will put it here. So it is like a dense layer which over just a surface. So this is a completely dense layer, and it has basically little bit low permeability and also have the low rejection. So it means the water comes out little bit more salty. So we need multiple passes of water, and however, it has a very good characteristic that it falls a little bit less as compared to the thin film. And thin film like membrane is in the right side on the bottom. You can see it has actually three layers. One is the support layer, then we have another polysulfone layer, and another over the polysulfone layer we polymerize another polyamide layer. It is called as interfacial polymerization. People who work with the membrane synthesis, they understand that how the polymerase interfacial polymerization works. So now what brings here, so if you can see here, what brings that this TFC membrane, we call this polyamide membranes, little bit improved version of the CTA membrane. It works in the lower pressure. You don't need to supply too much higher pressure above the, of course, above the our osmotic pressure, but the pressure kind of drop is less, and then high pH tolerant. You can use those membranes from 2 pH, which is very acidic, until very basic like 13 pH. And also longer life. It has a very nice, actually this polyamide is very close to the nylon polymer, people who understand the chemistry. So it's very close to the nylon. That's very stiff, very nice polymer, and also it can tolerate very high temperature. I will explain in couple of next slides that it can reach until 45 degrees Celsius. Otherwise this CTA membrane cannot reach 45 degrees. It has little bit issues with the rejection. Now okay, now this is the minimum energy concept. I will try to summarize these two concepts of the thermal and the RO process in single slide, although it is a very big academic question, or like even the very nice question we generally solve in our thermodynamics. So in thermal desalination, what is the minimum energy, and why the RO? We can say RO is a energy, how to say, minimum energy consumption in RO is much lesser than the thermal. Why we say? So if we consider the thermal, so as I mentioned earlier, in thermal we have to evaporate water from liquid stage to the vapor stage, and then back to the liquid stage. Now there are two thermodynamic processes are happening right here. Now one is evaporation, which is around 2300 kilojoule per kilogram. Again there is another process called as condensation. So it means if you sum up both processes, and it will, I calculate in the top, it is around 2256 megajoule for 1 meter cube of water, which is summarized, if we can calculate megajoule to the kilowatt hour. So it will, for 1 meter cube of water, you have to spend around more than 600 kilowatt hour of energy. Regardless of it is thermal, electrical, we don't go in that detail right now, but just think about the energy. Go on the right side, which is the RO. In RO it is a pressure based, so you have to apply the pressure to push the volume of the water to the other side, which is 1 meter cube equivalent volume. So how much we calculate if we have the pressure, if for example, so here the pressure, how much pressure we have to push? We have to go above the osmotic pressure. If you say 35,000 ppm of the water, milligram per liter of the water of the sea, this is the concentration of the sea water normally. So 27 bar is typical pressure of 35 Celsius. If you can see pi is equal to CRT. So we came up with 0.78 kilowatt hour per meter cube. See the contrast, see the difference of the minimum energy required to desalinate 1 meter cube. It means 1000 liter of water in thermal and the RO. So here the science, the physics or the thermodynamics contrast these two processes. However, there are still, we say the thermal process is more efficient in specific cases where the energy, which is the thermal, which is the heat energy, free from many industrial processes. So this is one of the thing I will describe in the this two concept in details also in another slides. Now let's focus what it matters in the process. So RO process itself, we simply say reverse osmosis, but it's really a big process which involves a RO process. You see a very small portion of the whole process. We have lot of portion in the upstream and also the downstream. Downstream, actually a one process we call as post treatment, which I will not describe today, but it is a one process that in the downstream. But upstream has a lot of process, and I will explain in a pre-treatment. We call it pre-treatment until water reaches to the feed pump of the RO. We call it as high pressure pump. And how it look like, these all membranes, actually we don't put one single membrane in RO, we put multiple membranes and in one, and then we put in a vessel. So you can see here just like a cartoon type of the image here, one vessel. We put around 7 to 8 membranes in one vessel in a commercial setting, but in normal small setting you can put 1 or 2 or 3 membranes in one vessel. And yeah, I showed here one of the membrane, how we put 7 or 8 membranes. Now I will explain, but just let me allow here to explain here the concept of leading and trailing edge. So in the beginning of the membrane, where this is the tail and this is the head basically. So in the beginning, you can see the water is little bit more less kind of the salty. Now we have high flow rate and high rejection, but when water goes towards the other end of the vessel, it is getting more and more salty. Now what happens? Because of the salty water, the last elements become more and more scaled, more and more calcium carbonate, and all the lot of inorganic components will get to scale in the last portion of the vessel. This is the vessel actually. And then in the beginning, what happens? There is another problem in the beginning, the biofouling. The microorganisms, they start to foul the beginning elements. So the two problems of fouling: the biofouling takes place in the beginning, and the scaling takes place in the last elements. Now let's start. RO process is of two types basically in our scenario. Most, like I would say 80% of the RO process is still seawater RO. We call it SWRO. But there are a lot of stations, lot of facilities, specifically our Indian context, lot of like shops, they have a RO process. We call it as BWR. We don't say SWRO. It's a BWRO because the water quality is a little bit less than 10,000 ppm of the salt. Now how we distinguish with these two processes? Basically, the SWR and BWRO is distinguished by the membrane. So the SWRO membrane is little bit more tighter, because it has to like cope with the high strain of the salt, and also lot of pressure we have to develop with the SWRO. However, BWRO can run with the less pressure, sometimes 20 bar, sometimes 10 bar, any of the such range of pressure. That's why it's loose basically membrane. And also our main energy, if we see in the bottom, so in the SWRO, our TDS more than 30,000 ppm, and we focus on pressure more than 40 bar, and the recovery is less. What is recovery means? The water recover is less in SWRO, and basically the pre-treatment system is relatively simple, although it has more contrast. I will explain later. But in BWRO, the water is the brackish water. It could be a surface water, it could be a well water. That's why it's less than 10,000 of the salinity. The pressure is always less than 40. It can be 10, it can be 15, 20, and the recovery is very high. Now see, in SWRO, the water discard, like waste is higher. If you see 45% recovery means we just 55% we discard to the sea. But in BWRO, the recovery is 80%. It means we can save 80% and we discard 20%. So many people have this misunderstanding. Oh, RO discharge lot of or waste lot of water. I would say it depends on the recovery. If we have a high recovery, we discharge or we waste less water. And I would say that the pre-treatment stage for the BWRO is more complicated. Although you see a little bit less constant, but if you see a little bit more on the higher scale, the complication comes from the divalent ions, because, and also a lot of silica, for example. Silica, I will not cover here for today's session, but silica is main problem for BWRO, where the silica forms a very insoluble scales. Now, as I mentioned, the feed is very important in the previous slide. It has multiple. So there is a specific requirement for the feed in SWRO. One of the thing is like we would say the turbidity. The turbidity we measure in terms of the index called as SDI, silt density index. So if the turbidity is very high, we don't use the RO directly. We do the pre-treatment. So there are some parameters which I put what are the requirement for the SWRO. SDI should be less than 4. TSS is the suspended solids. So it should be 1 ppm, 1 milligram per liter, less than that one. And the organic contents, because organic contents is very important. If we have higher organic contents, it will allow the membrane to foul much earlier than what we expect. And the chlorine, very important. Generally, chlorine is dosed in intake of RO system just to remove the bacterial development. However, it has to be removed before the RO process. Otherwise, chlorine is a very high oxidant, very strong oxidant. It will damage the top layer, which is the polyamide layer of RO process. That's why we have to remove that one. And the particle size of the suspended solids should be less than 10 micrometer. This is the reason we put a safety filter before the RO. We call this cartridge filters. So if the cartridge filters are removed from any of the RO process, our particle size increases and they will make a choking of the membrane. And the temperature of feed water should be less than 45 degree. Above 45 degree, the polymeric layer of the RO membrane will not work very properly. What would be the consequence of that? The consequence of that will be that it allows more and more salt to pass. It means its rejection decreases. So rejection is higher at low temperature and decreases when we increase the temperature. And the pH plays a very important role here. As you know, higher pH increases the, basically I would say increases the precipitation. So we have to see it should be around 6 to 7 pH. Otherwise, so that this 6 to 7 pH is very good for RO, because it allows the maximum of the salts to be in the dissolved form. It means the solubility of the salt remains in a good condition if the pH is between 6 to 7. If it is above 7 or 8, the salts start to precipitate. Now this is the whole process again of the pre-treatment. Here if we start that, we take the water from the sea and we dose the chlorine right away from the intake site. So we dose the intake the chlorine at the intake site, and then we basically do the screening. Screening means we don't want to fish and many things to come to our intake site, so we do some kind of normal mesh screening. We do the, actually this seawater had lot of suspended solid, lot of things that we need to remove but cannot remove by the screening. Is like a coarse screening. Now we put some of the coagulants like ferric chloride and some of the very similar. Right now people also put some of the polymer based coagulants also, but ferric chloride is very gold standard people use in the industry. We put like 1 to 2 ppm and it coagulate, and then we go for the DAF. DAF is the dissolved air flotation. So DAF will allow little bit more after the coagulation. Some of the particle will float over the surface and some will settle down as a sedimentation, and DAF will allow them to separate. And then what we'll do, we need to still separate it using some filtration. DAF is not a filtration. DAF is the process of just separating out based on their buoyancy, basically based on their density. But filtration process has to be done by some other filtration process. Here we use media filtration, specifically dual media filtration. Dual media filtration means we have two media. One is the main media, we call it sand media. Another is the supporting media, we call it anthracite or activated charcoal. And then we have the cartridge filter. As I mentioned earlier, the role of the cartridge filter is just to make the, how to say, the sieving means it allows only less than the particular size of the suspended particle. Previously the membranes, specifically the membranes from LG, membrane from GE and DuPont, they are allowing somehow 10 micron filters, but recently the DuPont or Toray membranes from Japan, so their requirement is to go to the 5 micron filter. So there are 5 micron filter cartridge filters before the RO, and then we have the RO process. Okay, now in terms of the process, most of the commercial plants, they run with the fixed recovery ratio. What does it mean? They know the consumption of the city, for example 100 meter cube per day. So to get this capacity, they have to run their desalination plant. It means they have to fix the output. We call this fixing the recovery rate or recovery ratio. Now how, and after that, what is changing? If you fix our output, what is changing is the pressure, of course. So the feed pressure on the left side is changing. If we are increasing the recovery, we have to increase the feed pressure. And why? Because lot of every day the foulants are increasing. Actually, the RO process is not very often cleaned. It cleaned with a very big cycle. It like maybe 3 months, maybe 5 months, 4 months, depending on the pressure drop we develop. So because of that, the foulants start to stick on the membrane of RO. So what happens? The feed pressure has to increase to meet the same quantity of output, and this comes with the energy consumption. Now, in terms of the, if we consider our energy consumption, so what are the components which consume the energy in RO? So there are basically 3 components in the left side. One is the high pressure pump, which is the main basically consumption, which is taking around 30 to 40% or 35 to 45% of the energy. Then we have pre-treatment system and the post-treatment system. Together we combine, they have the pumps, they have air scoring, they combine approximate, if we say the pre-treatment, post-treatment, around 10 to 15% or 20 up to 20% of the, if you consider the post-treatment, is around 20% of the whole energy consumption. Then we have the utilities. In utilities we have the automations, we have controls, we have valves, we have lot of the SCADA system, and also the clean in place, because as I mentioned, we clean after a certain time membranes, and we have the cooling system of lot of pumps and some other stuff. So everything will consume the energy. So in the right side, I mentioned that maximum of amount of our energy is consumed in 30 to 35% in the high pressure pump, we call it HPP. However, we have a benefit here. The energy recovery devices, we call this ERDs, can get back some of the energy from the brine, because we put like 50 to 60 bar in the brine, and output we may get around 50, is like 5 to 6 bar, or sometime less than this pressure drop, and then we can get that back that energy using some of the energy recovery devices. So we can recover around 20 to 25%, and we can minus that energy. So this is one of the best thing we get in RO system. Although in thermal system we also do the recovery of the heat, we call it multi-stage recoveries. So this is a different from the today's topic. So now in the right side in this graph we can see a little bit more on, this is the thermodynamic limit I mentioned in the previous slides. Now there are 2 types of the efficiencies, irreversibilities and inefficiencies. If we combine all together, it reaches to more than 2 kilowatt hour per meter cube. This is still ideal condition because no machine works in 100% efficiency as per our second law of thermodynamics. So it means there are always irreversibilities in the system. So we always go more than 2. In the left side, we see kind of the specific energy consumption started from 1970s. Actually, the RO's process started 1960s, but its commercialization started in 1970s. So 1970s we had around 15, 16 and 20 kilowatt hour per meter cube, and it drops very drastically. Even after 2000, when the polyamide membranes was discovered, it dropped further, and in 2022 we are reaching 2020 and even 2025 we are reaching very close to 2. Now there are some records of minimum energy consumption in the world. So the first record goes to our organization, basically SWCC, Saline Water Conversion Corporation, and then it was, I think, valid until 2025, which recently in Spain there is another desalro project which basically went down to 1.7 meter cube per hour. So actually there is a little bit I will explain in the next slide what are the main constraints that this energy goes to less than 2 or very close to 2 kilowatt hour per meter cube. Now the question comes how we can achieve this energy, because if you see normal plant, they always go more than 2 kilowatt hour, so more than 3 kilowatt hour per meter cube. But how those achieve those records were achieved less than 2 or very close to 2? There are like certain factors to consider. So one thing is the new membrane. They were using completely new membranes. If they use new membrane, there is a concept of, we called as the compaction. Before the compaction, the recovery is very high. I mean the salt rejection is high, the recovery, the flux was very high because the compaction didn't happen. And if the capacity is small, the performance of the many instruments are very high. And the feed water salinity, basically they have to optimize somehow. And feed water temperature, if the water temperature is higher, we get more and more flux. And the product water TDS, they keep very close to the WHO standard. WHO standard is 500 milligram per liter. And then the feed water quality, basically they see very optimum quality. For instance, in Saudi, if you test any system in summer, the feed water quality is worse. You cannot have the very good results. If you test any system in the winter, the feed water quality is very nice. So there is also the way to play around with the lowest energy. Now I have a couple of slides before I close for the environmental concern. What are the environmental concerns of desalination? So if you see, desalination produces 3 things basically. Number 1, it produces brine which has higher in salinity. It produces some of the chemicals which we use in the process. Third thing, it produces the heat of the machine. Even RO, it's not a thermal process, but still it produces heat. But if consider the heat process like another MSF and MED, they produce an enormous amount of heat. But it also so now how we have to discharge basically it. Let me go to the next slide, then I will explain. So this brine, which I explained in the previous slide, has to dispose of in the sea, and how there are multiple ways to dispose of. But let's see what are the concern right now. Actually there are a lot of studies. I mean, I give my opinion, my viewpoint. Definitely in the audience there are a lot of other opinions, but my opinion, this saline water has to go to back to the sea. And my own understanding is that it does not drastically changes any of the marine habitat or any kind of the marine environment. So definitely there are concerns, but I would say this is a little pinhole amount of water we are putting. See the surface area, see the evaporation is taking place every day from the surface of the sea. It is increasing the too much enormous amount of the salt in sea. Then we put a small tiny amount of brine in the sea. This is my own understanding. Definitely it may not be fully correct based on the different scientific findings. Now there is also the way that chlorine may go to the marine environment. It may damage the environment local, because the chlorine is not good for any of the basically our environment. And also there are a lot of things that could go I will put radioactive nuclides here. Why? Because there are a lot of things that if we take out the water from the very deep in the well, so those naturally they have some radioactivity, radon, they have the strontium, and they have some kind of strontium is very often find the radioactive strontium. We may discharge this to somewhere, this radioactive, and then they can actually enrich, they can get concentrated, not enriched but concentrated in some of the brine. So I think this is my last slide before, yeah. So I put basically 40 minutes, and I will allow the discussion to take place. I believe this whole the platform is mean for the discussion. So I just back to Dr. Hariharan.
Very, very professional presentation there from you, Mustakeem. I genuinely mean that. And thank you for your time on this. For the rest of you, let me remind you that Dr. Mustakeem is talking just now from Al Jubail in Saudi Arabia, and he's been part of the larger water policy in that country, as well as things that relate to desalination itself. Anyone who wants to speak up, I think we will open the floor. Like Dr. Raval said in the beginning, if some of you youngsters from the Nandi group, I must acknowledge your presence here, quite a few of you are here. If you have any questions for Dr. Mustakeem, that we will start with you. Then we will go to some of the senior veteran players like Mr. Reddy. Over to you all. Anyone from the Nandi group who wants to ask anything of Dr. Mustakeem?
Mustakeem, here it is Nehal Donde.
Yes, please.
During the process of this RO desalination, what about the wastage of water? Like, in the process, wastewater also comes out, because in normal wastewater treatment plant also I've seen the wastewater, it just goes waste. So what happens to that water and the reject which is there? So where this is disposed, the salt reject?
Okay, so thank you for the question. Actually, this is one of the question we always, the people who are concerned with the environment and working with the climate change, so they ask this question. So we have, our main waste product is the brine. Brine means the salt concentration, especially sodium chloride concentration, is very high in that water. And that water, most of the seawater, SWRO plants, they dispose of right now this water back to the sea. And this is right now the practice. However, there is another practice, but I think our organization is leading that practice, is zero discharge. What it means that they don't discharge to the sea, they extract the salt from there, and they made it so economic that they sell this salt much expensive than the discharging cost.
Mustakeem, the question that she was asking was not about seawater. It is to do with BWRO. Therefore, okay, you have to answer it from the context of the high reject that we have in the Indian condition, especially if I go to Western India, to Gujarat and Rajasthan, I find that the TDS level is as much as 2,000 in groundwater. Groundwater is available at 270, 300 feet. But what is the use? I get, TDS of 2,000. Her question is coming from there.
Okay, so I think in context of the BWRO, 2000, salinity is not bad. Basically it's very easy to treat, and but the thing is, what will happen? So assume if the recovery is 80%, it means we concentrated our feed to 5 times. It means if it 2000, we 5 means 10,000. The reject is 10,000 ppm. Now, if you dump it directly somewhere, it will create a problem with the soil. So I don't know what is the regulation in India, but it should be regulated properly, that the discharge of those BWRO should be very regulated. Otherwise, it will damage the fertile layer of the soil.
Hey, let me tell you the regulation here. What happens is, first, it is governed by the Pollution Control Board, not by the water authority, or the what is called the
Jal
GW,
Shakti.
the groundwater authority. It's not, yeah, Jal Shakti or Mahua. Here, what PCB says is, if I have concentrated salts of over 5,000, 7,000 ppm, that can only be evaporated. That means you cannot leach it into the soil, as you correctly said. Therefore, they create these tanks, these huge tanks. You'll see in many places in Gujarat, you'll see this. Having said this, I shall request Ravalji to speak on this RO reject water and what are what is it called, avenues for disposing of it. Ravalji?
Mustaqim, what is the regulation for reject discharge into the ocean? Because you said it goes back to the ocean.
Correct. Okay. Yeah.
Now,
into the ocean. Yeah. Yes. Yes.
what happens to the ocean? And first of all, what are the regulations that you have in your area?
Okay. Okay, I will not comment with the regulation, but the thing is, in the SWRO, everywhere in the world, everywhere they dump in the sea. Although there are parallel studies going on, but everywhere they dump in the sea.
But
no. That's not what he is asking.
Let's talk the physics of that.
Yes.
The latent heat of salt, which goes into the salt, whichever region it accumulates, it will keep on holding more heat from the sun. And there is a local thermal zone created. Even our Madras friend who delivered a talk on 450 MLD,
yes,
he had no clue.
You are talking of Mr. Madhavan.
Okay, thank you. So, entire global ocean water temperature is rising. So, where we are 25 years from now, or maybe 10 years from now, look, whatever sea that we see or climate, it's a titration effect. Titration is, we see the last drop which changes methylene blue to eosine red. That is the effect, manifestation point. But a lot more has gone through unnoticed, which contributes to this particular change. Now that change, whole global ocean is showing. Now, still, I appreciate the value of this technology, but that RO water is for survival. It is not for running the boilers. Because you run the boiler and destroy the sea by throwing that much of salt. Okay. Now, another physics part of it I want to bring here. Harji, it is of very much interest to you. Our blood pressure is 150 millimeter mercury, which is equivalent to 1.75 psi.
Yeah.
Hariji, 1.75 psi is 0.1 kg centimeter square. 0.123. And we are talking about 60 kg centimeter square. And Reddy Saab that day said 85. Look, for pharmaceutical is yes. But for daily domestic water supply, no. Because once the sea latent heat increases, all the icebergs will melt. And we have no solution for that. Chandra Sahab, you have something you have raised your...
Yes. Yeah. Yes, Chandra, you can talk. You have to...
Sir, I have only one issue to be addressed here. When I asked the chat GPT, what is the volume of spent RO membranes which are being disposed outside, there is no answer. I just asked for only Chennai city, because 96% of the rainwater is being thrown back to the sea. And again, there are desalination plants running close to the shore, which they claim seawater to drinking water. In that context, for a seminar, I tried to get this data. Data is not available. So my question is, where big and small, where all the spent RO membrane goes? No ChatGPT or any Google search gives a clear answer. I need to get this thing.
Mr. Kim, there are two issues here. One is, see, the moment we go to SWRO, you cannot simply say that everybody puts it into the sea. The question that Dr. Raval is asking, or even Chandra is just now asking, is that concentrated disposal of water into the sea from a desalination plant. What studies have been done in the past, since you're also a researcher, to show the direct impact on oceanic life from such indiscriminate or ungoverned disposal of reject water in the desalination process? That is one question for you. Please hold your response. The second question, if I were to go back to what Dr. Snail was talking about, in India or any country, the BWRO, although globally probably represents only 40%, as you said, or even less. The question for you is, if I have high TDS groundwater as we do in India, what can RO do to reduce the reject water, that is, enhance the recovery rate? I do not agree with you when you say the recovery rate is 80%. It is never more than 45% recovered, 55% reject. I can tell you in Ahmedabad, for example, for every 1 MLD, I do not get more than 450 KLD of water. You get that as permeate water. Similarly, if I do in a place like, say, Bangalore, when I have TDS of 700 or 800, I get no more than 50%. That is the range between the 700 TDS to 2000 TDS. The range of recovery efficiency is only about 5%. Remember, therefore, BWRO has a different set of challenges, and that is what she wants to understand, while Ravalji has a larger, deeper concern when he talks about SWRO. Over to you.
Okay, thank
Mr.
you,
Kim,
sir, for the first question. Actually, there are a lot of studies already have done for couple of the places, specifically Mediterranean areas. Mediterranean Sea. A lot of as Dr. Rawal mentioned about the Israel, which was having the good concept and the technology of the desalination they have done, and also the Pacific Sea. What is actually the context of whole the study? I will divide in two types, two parts of those studies. So one study, one of the group, they say, yeah, there are some impact, but the impact is localized. So it means there is a plume, and that plume has a kind of the diffusion, and it has to diffuse, and it's the localized impact, maybe a 10-meter diameter or something like this. And this is the maximum people they accept. Yeah, there is a localized impact, but that impact basically, because of the diffusion, it disseminate very fast because of diffusion when we go radially from the diffusion point, from the point of the diffusion. So this is mostly widely accepted, and I personally accept that thing if we do the simulation of such kind of the whole setup. So if we in the software, so this is my own analysis though. So that might be what is the impact? Localized impact means the sum of the fishes, specific, some fishes try to avoid that area. The two reasons: it is a little bit warmer place, maybe there little bit difference in temperatures. Second thing, little bit salty, so they will try to little bit far away from that we call as discharge place or the outfall place in technical terms. So this is one of the things. However, there are studies already have done that it impact the biotic community, that community which live from the a little bit bottom of the same place. For example, we have a one of the discharge point over the same, because the discharge point not only directly on the sea floor, it is a little bit on the above of the sea floor. So on the bottom where the biotic community lives, so they impact those community. This is the answer, my answer of the first question. So let me allow the second question. Actually, I don't know, there may be the little bit confusion in the commercial plants and normal household plants. So in commercial settings, so in BWRO, we overall the recovery could reach more than 80%. So our most of the plants which running by our organization, most of the BWRO plants which having the salinity approximate 2000 to 3000 milligram per liter. So all the plants, they are running more than 80% recovery. However, the recovery comes in a 2 stages. What it means, we go for one stage and the output, the reject of the first stage go to the feed of the second stage. So in overall recovery, it goes to the around approximate 80% of, I mean, you cannot recover probably 80% in one stage. So this is a little bit, I mean, problematic. If you go more than 60%, 50%, so it doesn't, the membrane does not, stay a little bit longer because it start to foul. So this is the answer of my, my answer for the second question.
Okay, back to Dr. Amit Singh has left just now. I don't know if it's because of poor network or whether whether he's going to return. That is the Ravalji's question. If you ask me, and maybe we should ask some of the other participants to speak. His question, you see, if you offered a simplistic explanation that, well, the diffusion is over about 10-meter dia and, radially, therefore, about 5 meters, and it's a very localized impact, not really affecting the ocean or the sea, it's not acceptable, really. We all know the complexity of such marine ecosystems, and the impact has to certainly be for a far larger area than simply this 10-meter dia kind of zone. Is not only my reading. It's, I think, so. I mean, common sense tells us that it cannot be as localized as you are suggesting it is. Also, we must remember that, as you rightly said, over 60% of this kind of RO process is being utilized for desalination across the world. What does that tell us? There will be a very, I will call it vested research, if you like, with multiple papers that are produced only to endorse the, the lower impact of such eject of water into marine ecosystems. We know how the world works, how business has to sort of happen. And therefore, civilization has, found this very perverted way of having research validate things. Ravalji, do you want to respond to him at this point of time before we invite others to speak? Or we can ask Mr. Narayan Reddy to speak, Ravalji.
Reddy sir, up, please take over.
Mr. Reddy, yes. Mr. Narayan Reddy, you're there? Yes, I think he's there. Yes, please. Go on. You have done your
Yes, sir. Yes, sir. Good evening to everybody. First of all, let me start with Mustake's lecture. One point he has missed is that in the process, the pre-treatment for the RO plant is the most important thing. He's nicely explained the whole process of RO plant, how RO plant functions and what is the theory behind the RO and what is the osmosis and reverse osmosis, etc., etc. Very basic knowledge he has given to people. Of course, people like us might be knowing, but there are several audience here. They don't know the basic things of the concept. He has nicely explained that. Thank you, Mr. Mishra, for that matter. And you missed one point in your process, pre-treatment process. That is screening, then coagulation and layer separation. Separation clarifier. After clarification, you have gone for the micron filter. That is the cartridge filters. The so-called cartridge filters cannot remove total suspended matter what is required by your RO plants. Reason is that you will not get the SDI, what you referred to, less than 4, will not come by your cartridge filters. So you have to go for the ultra filter in between the cartridge filter and the RO plant. You must keep an ultra filter. Ultra filter will give you the SDI less than 4. Otherwise, you don't get. I'm a practical person working in the industry. I mean, in my industries, etc. So our experience tells that without the ultra filter, it is difficult to achieve the SDI less than 4. And in the pre-treatment also, you must, because pre-treatment is cheaper than the post-treatment. Post-treatment in the sense RO treatment. How best you treat the pre-treatment, that much efficiency you get in the RO water quantity. That is, you said that 80%. My friend said that it is not 80%, only 45% to 50%. But it depends on the pre-treatment, sir. How best you treat the pre-treatment, and if you make it less than, I mean, in my case, we are getting 2 to 3 maximum CSDS. Otherwise, we don't run the RO plant. By doing this, the life of the RO plant, it increases, and the quantity of the output, it also increases. Because of the suspended matter, they go and block the RO membrane, and it will not allow further to go. And when it is not allowing further to go, you are increasing simply the pressure. When you increase the pressure, your energy consumption will go up. So for all means, you should have a better and best treatment for the pre-treatment. That is the point in his lecture. It is missed. I'm sorry. Don't think otherwise. It is a practical experience I'm sharing with you. Now, yeah. Ravalji, coming to your this thing.
Ready, sir. Just a point. Pre-treatment is not RO principle. Today's talk that focused on RO, pre-filtration and pre-treatment and ultra-filtration, they are not based on the RO principles. They are useful and contributing to the energy cost of RO is yes.
Yes.
But the principal application is not reverse osmosis. So we will keep it as.
I'm coming to your question. You have raised it just now.
No. I'm not questioning your ability.
No, not that way. See, you have raised in the forum that these are what is your energy, heat, etc. For that, I want to have some answer. It may not be appreciable, but what I mean to say, as he rightly said, that how rain comes by sunlight, by sun, it is a lot of water is evaporated from the sea, and it is going in the form of, vapor into the atmosphere, and an atmosphere cools it, condenses and forms the rain. The best way is that if you compare that much of heat, which is absorbed by the sea, and what the human beings are producing the desalination plant and transferring the heat to the sea is nothing. It is you can consider it as a minuscule, not much. Number one. Number two, if you want to go still more cautious and more these things, you should have stored all the rainwater. Somebody said that Madras is leaving the 95% of the water into the sea, rainwater and floods comes. And again, desalination working with high energy, etc., back to the drinking water. Yes, he's 100% right. Unfortunately, we don't have facility to store whatever the rainwater is coming to store in a storage tank, and use that storage water. That is the natural everybody is following universally. If you have that storage facility, it is excellent. That will consume very less energy and very less pollution also. The discharge also will be lessened because the rainwater will be hardly 200-300 TDS only, because it is falling on the ground and collecting. It will not be more than 200 to 300 TDS. So 200 to 300 TDS, if you multiple ROs reject water, RO reject water, again going for higher pressure RO reject water, and etc. 95% of the water, as I already earlier lecture I said that 95% of the water I am recovering. Sorry.
No. Somebody is talking.
Okay.
I'll mute it.
Yeah. So when the input water salt is less, your recovery will be more than 95% and 95% minimum you can have the water recovery, and 5% reject. As I said that the 5% reject, in any case you have to dispose facility. We have to find that is the alternative is only evaporate that 5% water and then make a total solid and go for a landfill. That is secured landfill. That is the normal process. Now going back to the sea saline water with the SWRO. as I said, that water heat, what you are sending back to the sea, or you are taking the sea water and you are not adding any salt to the sea. Whatever salt is there in the sea, that only you are taking. You are taking only the water from that and leaving the rest in the sea only. So by that way also you are not contributing additionally salt to the sea. You are keeping the salt, whatever it is there in the sea. You see, this is the today's science, what is allowed us to do. If better science comes and better equation comes or better these things comes, so definitely people will follow. As you said that 1997, what is the energy consumption to make 1 kl of water, RO water, and what is the today is phenomenal. So it is not even 10% of the energy what he was what we were consuming once upon a time. Today is only 2 kilowatt, even 2 kilowatt also more. Less than that, it is in practical. If you manage that, it will be less than 2 kilowatt. So for that matter, we should not worry for that. At this stage, there are a lot of other things to be managed for the human life for comfortable and the society sustainable environment, etc. See, this water, what we are using in the domestic water, we are using and draining into the atmosphere and pumping the lot of water with a high energy from the desalination plants from seawater and using and then draining into the atmosphere. If you take the treated water from the your effluent treatment plant, your treatment cost is much less than the energy what you spend for the desalination at the what you call that seawater. That is a 50 kg pressure or 70 kg pressure seawater membranes working. That much pressure pumping and consumes a lot of energy. Your energy consumption, if you take the domestic water recycling, that is purifying in a treatment plant and then filtering through RO plants and supplying to the domestic use. If not for drinking, at least for general purpose, water, if you make it, your energy consumption will be less, your energy environmental damage will be less. That is the thing. And yeah, if I don't know.
Reddy sir,
Rahul.
why I have one question to you.
Yes,
Why
sir.
didn't you volunteer to be a speaker today?
Yeah.
You know, it's easy to question, number one.
No. I am.
But most of the salt going back to sea doesn't make any difference.
Yeah.
Is not acceptable. The
What?
science of it,
Correct.
just the physics of it does not permit.
Coming to your question, rather than dying, living is always better. How
No,
do you live?
we
Is
will
the
have a
question.
session
How
from
do
you.
you live is
Otherwise,
the
we
question.
to
See, for example, Gujarat and this thing, they are having groundwater 2000 TDS.
desalination is for not groundwater. Period.
No, wait.
Groundwater is ultimate stupidity. You don't need a technology to correct your.
Then what is the how to live?
No.
Without water, you
Why,
cannot live.
why do you bring groundwater when there is so much of rain in Gujarat?
That is what I said in the beginning itself.
No.
If we can store the rainwater.
Sir, Reddy
My
sir,
dear
will
sir,
restrict to
listen.
desalination and not other source.
Wait. If you can store the rainwater, whatever raining is there,
The best solution.
God is created that opportunity. I mean, say this. He is
Don't
doing.
bring God here. We have messed up with the
No.
God. Please.
God means in the sun. Sun is our God. So, for all the life in the sea.
Sir, talk.
The earth, sun is only the God. No other God.
Ramji.
I believe sun is the God. Anyhow.
No, we have a
So,
session from you. Otherwise, we too will be talking, and others will have no chance to share.
No. See, Rahulji, I think the
Point
two
is-
others have raised, Mr. Reddy,
yes,
this
sir.
question of how. See, please mute yourself over it. I think Ramkumar, you have to mute.
Once again, I do not know my mobile.
I don't know why it becomes.
My mobile is.
Please mute it. Please mute.
Somebody wants to speak. I will start.
I do not know. Once again, I will get out and come.
So back to you, Mr. Reddy.
Yes, sir.
You said in passing, in fact, Mr. Kim also said, that this concentrated salts that are put back into the sea in the desalination process is not so much, relatively speaking, to the rest of what humanity puts out, etc.
Yeah.
What is Rahulji saying? Look, but you also said, well, this is the current state of technology. If there is some improvement into the future, we will, of course, embrace such practice. Dr. Rahul's contention is that, and I don't know if you can explain this, that the impact on the marine ecosystem cannot be as light as you and I are making it, or you and Mustakeem are making it. That there has to be a genuine study and research on the facts of what such harm is being perpetrated on the marine ecosystem. Is there anything like that that you can talk about, or he has to tell us what should be done? One of the two of you. See, even Snail Donde is saying, well, salts, higher salts in the sea as a reject water process is not acceptable. But somebody must be able to say what is acceptable, and what should therefore be done. Correct? Can one of you speak up, please? I think we had somebody else also mention something to that effect. Montu Lakhani, can you also speak up on this, please? Because you sort of agreed with Snehal Donde, but then you also said more or less what I am saying just now. Montu?
Yeah, good evening, everyone.
Good evening.
I am in this field from the last 25 years, and lot of different type of RO plant and RO membrane technology also. I am very well aware about these things, and I have installed a lot of RO plant also in my career. And regarding desalination, there is a whatever the reject water come out, that they have to take it inside the sea up to minimum 5 kilometers for the discharge. You cannot discharge at a one level. And
Correct.
what Mr. Rawal is saying, that there is a salt, salt latent heat and all. This theory is truly acceptable, but there is a functions that environment cycle maintain this automatically, because whatever the water we have taken out, and in the meantime rate of evaporation, rate of water is entering from the different stream, or from like rainwater, or you can say the glacier is melt, so that will get automatically balanced, and that try to minimize the effect up to certain manageable level. Suppose now we think in this direction. There is a city like Chennai, Bangalore, all are on the seashore only. And now everybody is, all the cities are very nearby, and all the cities are pulling the water, and reject they are throwing across the world. This thing is happening. So what Mr. Rawal is saying, that things will automatically hit the earth environment, and that effect will be seen in a very with a very high intensity way. But this is the few cities are doing, and part of this water is going again this, it will be managing in a such a way. Line is going, reject line is going up to 5 kilometer inside the sea level. So there is some minimization of this effect. But
Yes, sir.
If nature has its way,
No, Ravalji.
then deep sea is also part of this planet.
Sir,
And
Ravalji.
agree.
please allow me to speak, please.
Yes,
Go
yes.
on.
There is a book titled Blue Machine. It's written by a marine engineer lady. An entire heat cycle of the ocean through the salt concentration. She has covered it up extensively. So let's not engage more on that. Number two, coming to some other area of desalination. See, life did not appear in chemically pure water. There is nothing like pure water in nature. Try to understand. In RO, whatever the conventional RO water, it is 37 TDS, which does not support the intestinal flora. An entire B complex deficiency that we see in our society is mainly due to RO, which is not adjusted to particular concentration of carbonates, bicarbonates. My only point is, Pressure, efficiency, membrane, post treatment, everything is fine. Ultimately, two things matter to our health and to the health of the planet. For survival, desalination is absolutely acceptable, but not to have a lush green membrane, grass and stadium for the Sharjah Cup or whatever tournaments we have. Try to understand the entertainment value versus survival value. Thank you. Yes,
Rahulji, can you
Ramkumarji.
explain? Yeah, Rahulji, can you explain before we go to Ramkumar? You said permeate water doesn't support intestinal flora.
Exactly. This was raised earlier, some 3 months ago. Chlorination is effective for pathogen elimination up to 150 ppm hardness, calcium carbonate bicarbonate. Intestinal flora is flourishing at 200 plus. And ultimately, Dr. Thomas and all that, some 6 months ago, they mentioned PAA. PAA is effective for a pathogen elimination at up to 300 hardness.
Yeah.
Calcium chlorine hardness is finished at 150. So nowhere on this country, at least, where chlorination is the source of pathogen elimination. Most of my Bombay friends, they are on IP and all that. Ariji knows them. They, to save fresh water, they say use tube well water. And Bangalore is a lucky place, but Madras, Calcutta, Bombay, all seawater cities use tube well or marine water for flushing. And Hong Kong paid a heavy price. Hong Kong had 1,000 kilowatt, 2 working, 1 standby seawater pump, flushing the poop from sea to the toilet and toilet to the sea. And what price Hong Kong has paid in last 25 years, we know it. Now coming to desalination, Mustakeem. I forgot the name of the city on the west part, the lower west part of California. San Diego.
San Diego.
San Diego had 100 MLD desalination plant installed in 2011. They are very happy. So they installed one more in 2015, another 100 MLD. Third was 250 MLD installed in 2017 and 2018. All the three were discontinued. Try to understand physics, chemistry, biology, to theek hai, but what is happening world over? If we keep abreast with that, it will really, really help us. Hariji, you are trying to add something.
See, not in defense of anybody, but I'm saying that humanity does not know of any other way of solving their immediate challenge than by using by taking recourse to such technologies as are available. At the same time, you are right. In fact, Mr. Narayan Reddy also said this, that if we all decide, if an entire city like, say, Ahmedabad or Surat decided that it will create enough surface water bodies, as a matter of fact, we have them. If they only restore them and ensure that it is respected, that will drop not only the cost of such, recovery of water, but will ensure that we get far healthier water. This is, I think, what Mr. Narayan Reddy is also saying. However, as you and I know, and as all of us here in this group know, engineers tend to look for solutions for a certain problem at a certain point of time within a certain economic framework also, Rahulji. However much you might detest my saying this about the economics of it. Therefore, we have these very, recidivist kind of solutions that come up.
Hariji,
Rahulji, 1
cost
minute.
in 21st century will have to be looked with onto XY axis. cost to the pocket and cost to the environment. Any talk of economy based on cost to the pocket is over. That way, that phase is over.
Agree with you.
So survival is an issue, and for Middle East and Israel,
Sure.
I'm okay.
Yes.
With whatever.
Yeah. Ramkumar, you wanted to say something?
No,
Then
one point,
we'll
sir.
ask Amit Achpelia.
Very good evening. Very
Yes.
good evening. Can you hear me, sir?
Yes, please.
Yeah. I think Mr. Narayana Reddy has made a very important comment that Chennai receives a lot of water. In fact, Chennai needs only less than 50% of the rainfall what falls on Chennai. But he had made one comment that nobody is able to store the water. Am I right, sir? Reddy,
Correct.
sir?
Yes.
So it is very simple. Use the soil to store the water.
Correct.
Soil without water dies. The simple, distributed, very cost-effective, scalable.
Why are we not doing it? That you have to tell us. Don't tell us the solution. You have to tell us
why we are not telling we are responsible? Because all of us are in this forum are of very allied group. But the very simple solution, well proven. But none of us, many of us are not aware we can do it. And even if we are aware, we do not want to do it. And poor soil is dying. Chennai is sinking, I believe. And soil consists of, every unit of soil consists of solid soil 50%, 25% water, 25% voids. Simple shallow figure recharge, scalable, can be a solution to removal of flooded cities and water comfort for the planet for generations to come. I think this is one thing we have to spread it, sir. Because we are a allied group. We are a allied group. And we are not worried because it is not it is doable by the masses very easily. And if we are not keen to do it, who else will do it? In fact, one of the main important forums. And similarly, only one more point I wanted to make. Stormwater drain is throwing my water to somebody else's house. I made a plea even to the very senior members of the Chennai members of the CM's panel that make a drain harvesting stormwater drains. A thought leadership change. See, everybody who asks in a city why the flood is caused, they will say drainage is not proper. What we are doing, we are throwing the water which the soil needs to somewhere else. Only the runoff should flow outside. These are the 2 points which you have to consistently follow up because it is not easy to get it done. Because we are a water-rich country. Our group can play a role in this particular matter. And thank you.
Thank you. Amit Achpelia, you have a whole lot of people. Your expectations high when you invited all your colleagues at Nandi to also join. Any response from you after having heard Dr. Mustakeem as well as many others here? What is your take on it? What is your learning from it all? For the Nandi group, I'd say. Amit? And no, he's not. Yeah. Amit, you want to speak up? Or one of you from Nandi? No. Okay. All of you are listening. That's right.
One clarification.
Dalmia ji has raised his hand.
Yes.
I want one clarification on the RO.
Yes, please.
Sir, today RO plant water is not 35 ppm people are drinking. In the plant system itself, after the ultrafiltration or after the candle filter, part of water is directly connected to the RO water. That means, say, 2/3 of the RO water and 1/3 of the raw water as it is. After removing the suspended matter, it is mixed and given to 150 to 200 ppm or 100 to 200 ppm TDS water. It is given for the drinking. This is practical happening in any RO plant in the domestic side. Thank you.
Mustakeem, can you respond to that? You endorse what he says?
Yeah, I think I did not cover the post-treatment as I mentioned earlier in the introduction. So post-treatment is not covered. It's a part of the post-treatment, how we make 2 things, the adjustment of the pH and adjustment of the salt, the salinity, the TDS. So these 2 things are not covered, but it is as Mr. Reddy well explained. It's one of the, one of the process they do. So one of the things that, if you allow me to comment, Mr. Reddy is about the UF. Actually, ultrafiltration is not everywhere used. The purpose is we have to filter the the coagulants, we put some coagulant, ferric chloride, everything. Now we have to filter it. There are two ways to filter it. Either you use the ultrafiltration or you use the media filtration like sand filter. Now the problem why the most of the plants in Saudi Arabia phased out the UF, the ultrafiltration. Why? Because in ultrafiltration we have to clean the membrane every half an hour or very frequently, sometime 1 hour. So it has a valves problems all the time. So initially we used that thing. However, with the recent plants we are not using the UF. Recently there are some things, so it involves some kind of the operational problems. So now what is our main, the stream of the pretreatment? It is using the sand filtration as a dual media filtration to filter out the coagulants. So one of the things that mentioned also by Mr. Reddy about the cartridge filter. Actually, the purpose of the cartridge filter is just as a safety filter. It does, and it's not reducing the SDI. The main reduction of the SDI is done by the before the upstream of the cartridge filter. Either it is the sand filter or it is the ultrafiltration, whatever. But the purpose of the cartridge filter is not reducing the SDI. This is just a safety filter.
Sir, I will tell you the practical experience of mine. Your question that ultra filter backwash every time, every half an hour backwash. Yes, but at the same time, your DMF will not give you the SDI 4, less than 4, because their particle size reduction is coming only up to 10 micron, not less than 20 micron you get in the dual filter. After 20 micron, you are passing through the cartridge filter, it is reducing to 5 micron. But that 5 micron is not SDI, is less than 4. That is ultra filter only. What we do practically, I am telling, whatever the backwash water coming from the ultra filter, again circulated back to the dual filter. That is a DMF, dual media filter. We push back, and whatever the higher solids, etc., they remain on the dual filter. They get out again in the backwash of the dual filter. The dual filter backwash, again we send it to the what you call that pre-treatment. That is the coagulation treatment. There we are precipitating out total solids. The reject comes only from the coagulation settlement, the residue material only we are throwing out. Rest all these things we are recycling back and making it fit for the future, further processes. See, right. RO process required ultrafilters. Ultrafilter required DMF. DMF required again clarification.
I think Mr. Reddy, it's fine. It's absolutely fine. We don't want to go more details in the process.
Yeah, this is how things are recycling.
It will be a different process. We are not discussing the process in detail.
My point here is only to say that to safeguard the RO plant, to give more output without taking more energy. When it is scaling is there, you cannot every day you cannot wash it the membrane. Still we wash it once in 2 months and once in 3 months the membrane with the chemical treatment we give to remove the whatever the scaling is there in the RO membrane. This is the thing. That's all. Not much in this.
Got it. Back to you, Mustakeem. Yes, please.
So the one thing actually clear. One more point. People have the confusion that RO water is used for some other purpose. So RO water, specifically the continent I am sitting here. So RO water is specifically used for the potable. It does not use for the plantation. It does not use, for example, to cultivate for the grasslands or something like that for the stadium. Right now, I have a very full data with us, and it's completely banned here in Saudi Arabia to using your garden, using the desalinated water in your garden. There is another stream of water called as treated water. Now we have the water, all these things are connected with the treated water. So they have to use the treated water for such purposes.
I got that, but supposing I told you, this is a real fact I'm telling you, and I'm sure Ms. Narayan Reddy is also working in similar factories. You go to any glass manufacturing factory, you go to any steel manufacturing factory or a secondary steel manufacturer, right? They cannot use water which has anything more than 10 as mg per liter of TDS. What happens therefore? They're all using RO. For what? For manufacturing process, they're using RO, not for drinking water. Obviously not.
No,
Right?
sir, not 10 mg. We cannot use more than 1 mg.
1 mg. You see that? He is now talking DM grade water, Mustakeem.
We reduced in the RO plants to 2 to 3 PDS. Again, we pass through the DM plant.
In which for yours is pharmaceutical or what manufacturing process is that? Sorry, you have to unmute yourself.
We are in the pharmaceutical only.
See, pharmaceutical is one. In secondary steel, it is 10 mg they are willing to take. Right?
Yes. General purpose, yes.
No, not general purpose. They're also using it for their rolling mill or for their SMS plant or whatever that they use for in steel. So my point is, therefore, Mustakeem, for you, this is all BWRO category. I'm not talking the SW. Right? Most of India, people like Mr. Narayan Reddy are working in the BW category. Mustakeem, this is for you, right? What does that mean? It means that by and large in India today, if I take industrial water, which is about approximately, I will say, is about 60 billion liters per day, right, by Government of India figures, this industrial water, if it has to be treated and recycled, and ask him, Mr. Narayan Reddy will tell you how many times he is putting it through the RO process on an infinite cycle, right? This is the danger we have in India today. That is, I keep telling people, India does not have a problem of water scarcity. India has a problem of very high TDS in the groundwater that it has. I'll stop there now. Mr. Gopal Dalmia, I think you should speak. Yes. Haji, Gopal.
I request Mr. Mustakeem to respond first, followed by Mr. Reddy. Both have spoken mostly on the RO part, and I understand that today's presentation is on the RO. But there was an interesting comment by Mr. Mustakeem that they have a zero discharge. I mean, they remove the salt and sell the salt. So that is one part of the treatment which we have somehow skipped today. And it would be interesting to know from him what is the final treatment they do for evaporation of whatever water is available and make the salts available as salts or any other chemical as a chemical to be used further down by any other industry or by human consumption. I understand that Mr. Reddy had told us last time that they make the solid discharge and is safely vaulted into some place dump which the government has permitted them to dump it out. But that is also similar to the salt recovery. So first Mr. Mustakeem, followed by Dr. Reddy, and preferably nobody should disturb either of them when they are speaking. Otherwise, we will not catch what they have to say. Thank you.
Okay, thank you very much. It's a very interesting question. I didn't touch this topic intentionally because this is a different direction. However, just to respond to your question, in Saudi Water Authority here, so what we do, we are producing 4 specific chemicals from the waste of this brine waste. One is sodium chloride, very pure quality, like 99.8%. 98 to 99%, 99.8%, and this chemical NaCl, this high quality, is required to produce the sodium hypochlorite, which is a disinfectant. So this is one of the what we do. Second thing, we do the veterite. Veterite is a form of the calcium carbonate, and this is used in the pharmaceutical, and also this is used in the we generally use this toothpaste and everything. So this is one of the the salt we produce as a veterite from the same waste of a desalination plant. Third thing, what we produce is the bromine. So bromine we also produce from the reject of the desalination plant. And the fourth one, what we produce is the magnesium. Magnesium is, as we all know, is a very precious metal, and right now we have magnesite and dolomite, these type the ores that conventionally we use for the magnesium. However, recently we have successfully extracted the magnesium as a metal from the sea, and then we have a commercial, basically, we have already done the piloting and we are moving to the commercial plants. So these are the few chemicals or the minerals that we are extracting from the waste.
Yeah. In continuation to that, sir, Mr. Dal, the practicing people in the seawater utilization, depending on the product requirement or the company or the manufacturer's necessity. For example, Nirma is there. That is they produce a lot of sodium carbonate and they use in their detergent. What they do, they take the seawater, they do the desalination, they concentrate the salt, and the concentrated salt they use it for the converting into sodium bicarbonate. This sodium bicarbonate they sell in this thing. In the process, again, it is not that zero they are making. Again, calcium chloride is byproduct. It will go back to the sea again. See, what I mean to say is that nothing is created, nothing is destroyable. Whatever it is there in the universe, we have to transfer from one form to another form only, and which is safer to the human life. That's all. To the extent possible, whatever the science today available, to that extent we are working. Tomorrow some better science comes, maybe we will reduce that impact also, environment impact. This is one example for the seawater desalination, and they are converting that salt into the useful product. But at the same time, end of the day, something is coming out from that again. It is the calcium chloride. It is going to sea. So there is no end for this. What I mean to say. Yeah.
Ready, sir.
Yes, sir.
Then what is wrong in pumping wastewater into the sea?
What is the wrong in?
What is the wrong in pumping wastewater freely?
No. Wastewater, you can see there is a limitation for that.
No, it's part of the planet. It is nature auto mode.
No. Wait, sir. There is an impact on the seawater. Sea living creatures, they die if you pump more organic into the sea. They don't find the sufficient oxygen for that, and they die. So that is why
coming to Mustakeem,
standard given by our regulatory given standard. So much of organic should be there, not more than that.
Just
and there is no limit for the salt.
One more layer to recyclability is auto mode. Everybody is talking. Mustakeem, the membrane is cellulose acetate. Hariji, we are coming to the epicenter. That acetate is the chief constituents of activated sludge. Just imagine 100 RO plants membrane reject, not chemical reject, membrane discarded, which is a chiefly acetate molecule. How do you recycle that?
Sir, they don't recycle, sir. They dump it. That's all.
Exactly.
No.
Thank you.
What acetate? Sorry. What is the acetate you are talking? Which acetate is coming from the reject water from the RO plant?
No. Membrane.
Reject membrane.
RO membrane is.
RO membrane reject. Yes, it is there. That is only the solution.
I am not talking reject, sir. I am not talking part of the filtration process.
He is talking of the membrane that is being disposed indiscriminately, Mr. Reddy.
Membranes which are formed for RO plant.
Correct.
I am not talking seawater, hard water, anything.
No,
like
correct.
my cloth, that membrane is a layer which is formed from cellulose acetate.
Correct.
Now, when we reject membrane of 100 RO plants, suppose, what happens to that membrane?
Correct.
I did not get your question, sir. But there is nothing.
For example, I throw away. This is cotton.
As you said that.
No,
your example.
Let me respond.
Try to understand my question before answering. This is my cloth, which is cotton.
I agree.
I throw it away somewhere after I have used it.
Yes.
That is a solid waste.
Yes.
And cotton will take its own time to be recycled in nature.
That's not recycling. It is converted by the nature. Bacterial degradation will come and go to the atmosphere.
That in the form is recycling.
Of carbon or in the form of carbon dioxide or in some form it will change. That is the natural course.
Correct.
Then throw all the STP water and stop your STP plants. Let industries go.
You can, but there is a limitation for that.
Thank you.
There is a limitation for that. If it is your food, you are taking daily some half kg of rice. For example, you take 3/4 kg of rice, you will get die. Food also poison for the human being if you take more than the required. Anything which is more than required is a poison. It will upset the total system. It is not that. See, there is a limitation for everything and anything.
I think
So we have to be within that limit.
Mr. Dalmia yet.
Yeah,
Yes.
we have to be within the limit. As long as we are within the limit, it is okay. But still, there is some damage is occurring for the environment.
Yes, Mr.
So we have to look for the what
let's
best
go
we
back
can
to
do further.
Sir,
That is the
Anji,
thing.
Gopal Dalmia.
Yes,
Let's
sir.
go back to
RO
Mr. Dalmia.
membrane manufacturer,
Mr.
sir, the RO
Mustakeem.
membrane manufacturer should come out with alternative materials which has some recyclability. That is one subject of research. And also the disposal needs to be recorded properly. That is
Very
the
well said.
message, sir. Thank you. Yeah.
Very well said. Very well said. Thank you. Back to yes, please. Go on.
My request to Hari sir and in the process to Mr. Mustakin that in some future presentation he could perhaps share how they do the recovery of the final solids like the sodium chloride high concentration purity and because I remember in my school days we had made a small still with a glass cover and put some ordinary water in the basin which was hermetically sealed. So the sunlight would evaporate the water under the glass and it would condensate, and because the glass is inclined, it would fall to the lower side, and we would take the distillate and make it useful for battery, lead acid battery distilled water requirement. Now, as an experiment in school, we ran it for a whole year. That's all right. But if you think of a scalability, because finally we are removing the water, that 5%, as Mr. Reddy said, the final 5% has to be evaporated. Now, sunlight is usually plentiful in our country and also in Saudi Arabia. Whether such reject water, the final 5%, can be evaporated with the help of sunlight for 8 or 10 months out of the year, whether it is commercially feasible, that is one part, and the other is the chemical process or the thermodynamic process by which they are recovering the different elements like the refined salt and bromine and calcium, etc., which is usable for other downstream utilization. It's an interesting fall through or development which we cannot cover today.
So Mustakeem, our learning from what he says now, what Mr. Dalmia says is, we have to have one session for pre-treatment RO. Mustakeem and Mr. Reddy is also one of the experts. And of course, Rahulji will have to endorse this. And Snehal Dondeshi, I request her to speak now after this. Second is this downstream process post-treatment that our Mr. Dalmia just now explaining about bromine salts, etc., which you know. We have to have two different sessions, I think, on these two. I think in a way, somebody just now agreed. I think it was Mr. Reddy who said that, look, we accept that. No, someone else spoke prior to that. I think Mr. Dalmia said it, that these challenges have to be taken as opportunity by either scientists or engineers to see that we have a different state of art of technology into the future, which will obviate some of these risks that we have currently of the reject water and the high concentrated salts. That's all I will say to that. Snehal Donde, I think you should speak from the context of, are you there, Snehal? Can you say hello to us? Yes?
Yes, I'm there.
Yes. So, I mean, first I must say that credit goes to you too for curating such programs as this one. From your context of government, administration, and challenges of RO sometimes that they use, mostly they don't, you know how processes there are, they confined to the tertiary level only. Do you have any takes that you want to share for the rest of the participants here?
See, today, mainly my interest in this today's session was to know that when we are talking about desalination, basically this desalination is not required by our country, first of all, because we have plenty of rainfall. So we don't require at all. Okay. But the countries, those who require, I understand they have to undergo a lot of research about how they are going to work with the reject that brine which is there, which is more toxic to the marine organism. We cannot say that it goes to a specific place and specific place it remains and there it is going to harm. It's not like that. When we talk about the ocean, there is waves, winds and all, current is there. So with that, it's going to move. And already we are hearing about the leaching of the corals and all, acidification and all this, and also about the temperature. So we cannot at all overrule that this reject of salt will not harm at all. So it's better, first of all, from my point of view, so we should not go for desalination in our country at all, first of all. Secondly, RO also, when we are talking about, Ravalji very well said about the membranes and all, because see, these are what we are talking about, the artificial membranes which we are creating, and we feel that we are able to mimic the nature, which is not possible by us. So it is always better we should go about in the natural way only, and that's why we always call it as a nature-based strategies. Yesterday I was in yesterday I was in again that same storm water pumping station at Dharavi, which they are planning in Mumbai. 18 such stormwater system pumping station, 18. And where they are planning this? On in the mangrove islands only, in the mangroves, which themselves have the capacity to all the work what we are talking about, RO, or we are talking about the stormwater pumping station. They are the natural this kind of an infrastructure for us. Why can't we pour more money in restoring them back instead of bringing in this kind of an artificial infrastructure? That's what is what I would like to say here, because I am not let me tell you very frankly, I'm not happy with for what I had joined. I wanted to hear, is there any way out, because already 2 desalination plants have been approved in Mumbai, and 12th I have a meeting with all these all biggest of the chief engineers and the commissioners and all. I wanted to put it before them. That's why I tried to join today, to understand
Very
about
nice.
what are the impacts of each stages of this desalination, the process which we said from pre-treatment to the post-treatment, and the rejects what we are talking about today. Because basically most difficult aspect today of everything is the reject part, where it is going to go and then what it is going to make an impact, because that is leaving a very lasting impact on all of us. And that's what is going on, giving like even nature is giving us an indication so alarming. Today also there is a lot of cyclones happening in Andhra Pradesh and Sri Lanka and everywhere.
And
Full year like we are facing all this. So why are we not stopping? So that's what is my
the good thing that you raised or mentioned in passing is about the 2 ROs that have been approved by the state government in Maharashtra. Now, as you also rightly said, this pre-treatment process, we shall request both Mustakim and Mr. Narayan Reddy to explain what those are in a way that you can put them as recommendatory framework for these ROs, because the moment we address the pre-treatment concerns, what happens is it softens the blow or the ecological damage that comes from out of the RO process itself. Ravalji was right when he stopped. He stopped, I think, Mr. Narayan Reddy at one point and said, "Today's discussion is not about pre-treatment." I agree with that. But Ms. Dalmia reminded us again that we must talk about those 2 aspects which precede and succeed, as you said just now, Snehal. And therefore, we will probably request the same Mr. Kim and Mr. Reddy to see if they can present to us some recommendatory framework which you can take to the state government on pre-treatment, coagulation, how to address those before they put up the RO process. Yes, Mr. Dalmia.
There
Yes,
is
I
an
will add, Dalmia ji, just give me a moment,
Yes, go
because
on.
what Hari ji said, so I just want to add there.
Yes,
See,
please.
when I am going to these authorities, I want to ensure that they are not going, they have to drop these desalination plants. The only the reason because if I have to look at that where they are making this, creating these plants, it is on some 30 hectares of mangroves. So I have a question to them. Can they tell me that what capacity my this 30-hectare mangroves don't have and your desalination plant have that? Okay,
Very,
because
very,
that
very.
is the most biggest thing. because nature has gifted us with such infrastructure to take care of everything automatically. Why
Excellent.
we are interfering with it? That is
Very
what is
good.
my point. So
Absolutely.
I don't want to, means like the things which I don't know about much, like pre-treatment or post-treatment and all, I don't want to get into that at all. First, I want to ask this only, that where you are creating this infrastructure for the storm water drainage system, pumping station, or this sewage treatment plant on the mangroves itself, on desalination plant. So
Mm.
how will they justify that? Instead, that
Absolutely.
60, 70 crores which they are pouring in for this infrastructure, artificial constructed infrastructure, if I put the same amount in reviving these mangroves and creeks and all, I think our work is done. Soil is there, all these things,
Fantastic question.
a lot of capacity.
Fantastic question. Gopal, you wanted to add something before that. After
Yes,
that, I'll go back to Mr.
there is an interesting concept which has struck me just now during this discussion is
G.
that there is this stormwater which we are letting go into the sea from where we are taking water for desalination, and we are speaking that we have extra water in to begin with. Now, if it would be interesting, Rahulji can also chip in his point of view on this, that during the rainy time, if we have certain small catchments which can actually pump the water into the larger storage, like the Red Hills in Chennai, for example,
Mm.
which may not receive its fair share of the catchment in the first place. But if you can pump it back to your main storage, then you can use it in the dry season. So when we have plenty, can we send it to our storage, like putting into our bank, and draw from it at a later stage? Some kind of a pre-treatment so that the stormwater is treated sufficiently, so that there is no deposits which will affect the storage area.
Yeah.
But
Yeah.
like our water bank, so to say.
I get that's blue sky thinking you're doing. The governments will know how to even understand what you're talking about is a question. Mustakim, I think what Dr. Snail Donde has raised for you is very, very important, right?
Okay.
The that is you see what she is saying is effectively she came in today to listen to you only because she wanted to know, is there a way of doing away with RO for the scales of, for anything that is on a city scale? Is there a way you can address that? Go beyond. You see, you are a researcher first. You are, I would like to think, at least, Mr. Keith, that you are more inclined towards ecology than towards engineering. I would like to think that you are like that.
Okay,
Now,
sir.
yes. So Mustakim, you have to see that book he's talking about, Blue Machine. Clearly, you must read it. As a matter of fact, this book, you and Mr. Narayan Reddy have to read it because there is very, very explicit documentation of the evidence. Her name is Helen Zersky. And I'll send you the detail, Mustakim. And to Mr. Narayan Reddy also, I'll send. So all I am requesting you to do is, as experts in the area of water, what are those options beyond RO that can be recommended to a city? Like she said just now, she gave an example. I'm not saying she's right or wrong. She said, if I have the same 70 or 70, 80 crores or whatever, and if I were to put that into creating some natural ecosystems which can serve the same function that an RO can, that would be a better option to take up, she says. See, it's a very audacious statement she's making. You know, she's not coming from being an engineer. She's coming from being a very demanding ecologist, I will say, right? How do you answer that question? You must see. Chandra, please respond. You want to say something? Chandra, you want to talk? You must unmute and speak, Chandra.
Yeah, yes, sir. There's an
Yes.
answer for what. Yeah, there's an answer for what Snagel Donte had suggested. Phytoremediation has been proved millions and millions of years again and again. Suppose the same mangrove is being concentrated, more saplings are being fed into that same mangrove and revive that mangrove for that same 80 crore rupees. I wish phytoremediation will take care and the microbes within the soil will take care of any type of contamination which comes in and it will clean the water. So I go with her. No RO needs to be. In fact, RO should be banned boring water in the country should be banned. These two, if they are banned, we will prove how we can survive. That's all, sir.
So very, very nicely said. Thank you. See, Mr. Kim, to you I'll say, not to Mr. Narayan Reddy, because Mr. Narayan Reddy comes from being a certain kind of a consulting professional in the area of water, and he has a clear agenda for the companies that he serves. However, for someone like you, although you hold a job right now in some desalination, and I know where your heart lies, you are very capable, given your academic rigor, to be able to offer in the next few days, and I shall help where I can to give you a few more people. Dr. Raval is anyway there, to see that we give a clear, what should I call it, a schemata that Dr. Snail Donde can present to the state government and say, these are the reasons why you should not do RO. And if this money is spent like this, in this time frame, the same impact that you get from RO shall be secured from the other option. I don't know what the other option is. Is that something that you would want to consider taking up, Mustakeem?
Okay, thank you very much. Actually, this is one of the very interesting and very important question I would like to answer here. So the first thing we have to understand, what is the priority of the government? The priority of the government is to supply the safe drinking water to people. Now, there are multiple ways to get it, but government is not a research institution. Government is not something that they will go and just see how the nice. So government will allow the stakeholders to open their channel. Okay, this is the problem with the city. Please come and solve this problem. Some company came and then proposed the solution. You have to spend 1 billion rupees and whatever, and then we will provide this amount of the water to you. Government is finished. Government done. Government does not care anything. This is the mentality of the government. Now, however, coming back to the point where we can leverage this concept. Now, my point here, what I can see here in Saudi Arabia, and you will see in many other countries, desalination, we expected, in early 2020, we plotted chart, what is the expected growth of desalination until 2030. But you will surprise, the rate what we decided to growth of the desalination is declining. Why? Because there are a lot of, first thing, important thing, the country here, I'm just again giving the example of Saudi Arabia, the country was very committed to provide the safe drinking water to everyone. This is the first commitment of the government. This is the purpose. Now, once they reach that commitment, now they are going from bottom up approach. What they do, they are trying to treat the wastewater, and they are allowing people, okay, if you have a garden, you cannot use the desalinated water anymore. If you have the car wash, now they are going to use the different scenario to create an impact. What is happening here?
Yeah.
A good percentage of the water which was said desalinated was using in another potable water stream was cut off.
I agree, Mr. Kim, but see, your situation in Saudi Arabia is very, very different. Number one, you get only 150, 200 mm rainfall. Bombay gets 3,000 mm rainfall.
Yes, right? Yes, I am getting this point now. Let me, coming back to this point now, in Indian context.
No, that is what Snail was saying. See, what he is saying, Chennai is getting 1100, 1200 mm rainfall these days.
Yes.
In a country like this, it's so much rainfall, average of 1 meter. Why should I be doing all this? He's saying.
Sorry to interrupt, sir.
Yes, please.
Scientists need not come into picture. If the collector has authority and the local tahsildar has authority, if he can remove all the encroachment, all the ponds and lakes and rivers are retrieved, enough water can be stored in all these places. Chennai, Chengalpattu and Kanjipuram had more than 400 ponds and lakes around Kuvam and Madaya River. Now only 30 or 40 are existing. What happened to the remaining 90%? That is the job of a tahsildar and the collector. If they are really good.
I got it. Okay.
Okay.
So
Let me just
intervene. Yeah.
Let me just finish the last part. Very interesting. And really, sir, I really appreciate that your intention and your consistent pursuance regarding what we can do in the Indian context. So Indian context is completely different from Saudi Arabia. Saudi Arabia, we don't have any option. We have to go. But what is common in Indian and Saudi context is the commitment by the government. Government is committed to provide the safe water. However, what we can do, how we can help the government to provide an alternate of the desalination plant. For instance, the two plants already sanctioned. I believe they, I mean, there are a lot, two companies, probably L&T and some other companies, they got this one. Now, the point here, how we can do in the reuse of the wastewater and also the catchment of the rainwater. These are the two very nice golden areas what we can explore. But how? Again, the commitment of the government is very important here. So government will not trust until we show a very nice example, because these things are participatory, social participatory. If the people don't participate in such things, it will fail, and people have the scarcity of the water.
Yeah, sure.
Mustakeem,
So
we have 5 rivers in Mumbai. All are converted into drainage. We are saying if we can revive those rivers. Mithi is such a big river. Okay,
sure.
and along with that other rivers are there, and Mumbai is also city of lakes. We need to revive those lakes. We have already been talking about all these things, because see, for the Mumbai's water, we transport from 120 kilometers from the village regions of 5 6 different rivers, Bhatsa, Vaitarna, Tansa, like that. And again, we have also built one after the other, and now a new one is going on, Gargai Dam. Earlier it was Pinjal. So we are going on constructing dams after dams, or we are transporting more water from far distance instead of reviving our own water bodies. So that's
This
what
is
we mean. And another thing, 3,000 of rainfall, not a single drop we are catching.
I
So
agree.
so much of potential. That's what we are trying to convince our government.
Yeah,
this
once
is very
again, can I
important. Yeah,
request
sir,
one more?
just like,
Yeah, go ahead, please.
yeah, this is one of the very important point. We have to work in this actually niche area. So this is what we require a little bit more I mean, kind of like discussion, how we can revisit our back to the system, like recovering the water from the canal or from the river, something like this.
I got that. Anyone from the Nandi team, I can see that many of you are still here after nearly 2 hours. Anyone who wants to speak up and offer some comments from the Nandi team? All those who are under the Amit registration. Anyone who wants to speak up, please. Okay. One last thing I thought is I must ask Ume Amara to see if you can offer any opinion or insight to what Mustakeem has presented and what the others have responded to with. Would you want to speak up, please, Ume Amara? No, she's well, it's still muted. We shall leave it there. I think we have spent enough time today. One very good outcome, thanks to Snehal Donde, is this. Mustakeem, you have to wear a new cap of the ecologist and not of the engineer, and see how you can offer some solution for what she is working on. She is in the same group, in the science group that I have also included you now. Let us continue the conversation there, but we will also take what Mr. Gopal Dalmia said of having 2 sessions, probably, or 1 session on pre-treatment and post-treatment together, whichever way you want it, you and Mr. Narayan Reddy. I'll write to both of you. I'll also include Mr. Narayan Reddy into that science team, and let's see how we can continue the conversation. If we can give something to Snehal Donde, because she's been championing a lot of things. I mean, truly, I'm telling you, there are not enough leaders like her who go out of the way to see that they can get something done with the government. And she's extremely positive about the government all the time. Only thing she keeps saying is we have to give them solutions, otherwise it will not happen. Let us see what we can do to help strengthen her own, ambition on this one. Yeah. Thank you so much. I think Ravalji has also left today. Thank you, Chandra, for being here after a long time. Appreciate you being here. I know your concerns in these areas. Sarla Shanti also, thank you so much for being here.
Thank you, everyone. Thank you, Mr. Reddy also. I think we have to
Thank you,
connect
Mr. Reddy.
Yeah.
It's
very nice
you,
comments.
Mr. Reddy.
Yeah,
I
very
will
nice
include
comments.
you in one group. Sorry, Mustakeem. Go on. I interrupted you. Go on. Go on, Mustakeem. You want to say something? Okay. So we will include you there, Mr. Narayan Reddy. Let's see how we can take it. Yeah. Thank you so much. All right. I shall sign off now.